I will teach you how to make this. I have just this and this. In order to do that, you're going to have to understand a metaphor. This metaphor is how the Rubik's Cube is like a highway. You've got places to go and roads to travel between them to get there. I'll first be telling you the places of the Rubik's Cube, then I'll be telling you about the roads of the Rubik's Cube, and then you will have the tools necessary to create the Rubik's Cube out of just pen and paper. Now, if you were designing a highway, you had buildings, you'd say this dot, each dot probably represents a building on the highway. And you might be asking me, how does the Rubik's Cube, which is a highway with 43 quintillion places to go, have all of these dots with these roads all fitting in the palm of your hand? And that's a very good question. And it's very impressive that they did that. And I will be showing you next how exactly they did that. Now let's say Ray, Ladybug, Baby Jack Jack, Scooby, and Peppa Pig were all going to dinner. Now they all sit down in their 5 chairs. There's a lot of different ways they could sit down in these 5 chairs.
Correct.
Peppa Pig could sit next down to Ray, like this. Or maybe Peppa Pig would sit next to Shaggy. Shaggy would sit next to Ray. There's a whole lot of different ways this could go down. In fact, there's 5 factorial ways it could go down. That's 120. And if we could label each one of those as a specific place, then that would be a really efficient use of space to create a very large highway, a very large number of buildings you could store in just 5 places. And that's exactly what the Rubik's Cube does.
Interesting.
So, each one of these, Peppa Pig, Jack Jack here, all of the rearrangements are different places you can go, different buildings, just like the gas station, your house, on a highway. In the Rubik's Cube, all of the guests at the dinner party are all of the stickers. Imagine this is a stickered cube, and all of the seats are all of the spots on a cube. So if you peeled off all the stickers, all of the spots, black spots, would be the chairs. And so, just like with the example with the dinner party guests, we can store, red sat here, this red sticker sat here, this white sticker sat here, this white sticker sat here, and so on and so forth. So now you've got all the buildings on the highway and you need to create the roads. A highway, it's very simple. You just build physical structures between them. But with the Rubik's Cube and the ideas I laid beforehand, it's very difficult. We do not have a physical location for each building. It's a combination of all of the permutations of the people at the dinner party. So, building roads between them is going to look a little bit different. I'll show you that next. So now that we know how to store all the buildings in a highway as guests at a dinner party and where they sit, how do we travel the roads to get to other places on the highway? So, well, another location on the highway is going to be that location. It could also be that location. It could also be that location. But we have to create rules for which locations have roads between them. Just like there's no direct road between you and the White House, there's not going to be a direct road between any 2 places on this highway. So what we have to do, and what the inventors of the Rubik's Cube decided to do, is they made rules for how people at this dinner party can change seats with each other. So, for example, a rule might be, maybe the rules of our highway is that you can only switch seats with the person at the head of the table. So, this is a road, this is a road, this is a road, and this is a road. And I've just traveled all 5 of the relevant roads, although, and yeah, this is a valid game. The Rubik's Cube just has different rules. And, you know, another rule might be, okay, everyone can go 1 seat counterclockwise. Another rule might be, these 3 people can go in a circle. So this person goes here, this person goes here, this person goes here. And you can create a very large number of games. For n seats, you can make 2 to the n factorial games, which is extremely large and entertaining. So how do the roads on the Rubik's Cube work like dinner party? How do the roads on the Rubik's Cube work like the dinner party? So, all the stickers are going to be our dinner party guests, and all of the black space underneath the stickers, you'd imagine on a stickered cube, is going to be the seats that people can sit at. So, just like the moves might be, so this is the move, and that means this guest moves here, can move here, and this guest moves here, this guest moves here, and this guest moves back here. And if you notice, it's always going to end up in a circle of some sort. So it's going to come back to where it started. So what you can do is you can write out the circle. So you can write out this person's going here, going here, going here, going back here. Or I think it was this is here, 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 and back. So what you're going to do is you're going to write, let's call this guy A. A goes to B. We're going to call this B, C, D. Goes to C, goes to D. And then this big old arrow. And, you know, obviously this is a lot to write, so you could just write A, B, C, D. And then with parentheses, and we're just going to understand that means this goes here, goes here, goes here. And so all we do is we have to label all the seats, label all of the guests with numbers, and then we are ready to record all of the valid roads for the Rubik's Cube. So what I'm going to do is I'm going to kind of use, let's do Spef's lettering scheme. So we're just going to call it like A, B, C, D, E, F, G, H, and we'll label it with a corner or something. So this is going to be A, then we'll do subscript corner, and then B subscript corner, and then we'll do A subscript edge, and so on for this B subscript edge, C subscript edge. So what does a U move do? So U move, since this guest here, this guest here, this guest here, this guest back here, so that's going to be A corner, B corner, C corner, D corner. Alright, and then A edge, B edge, C edge, D edge for this here, here, here. And then we got more corner stuff going on. We got F, R, and J. And then we got E, Q, M, I, And then we got one last one. E, Q, goes to Q, goes to M, goes to I, corners. And so this all together is one of the 6 moves on the Rubik's Cube. And we just have to do that for all the other 6 moves, and then we have recreated the Rubik's Cube. If you'd like to also create the moves for double moves, counterclockwise, you can do that, but it's going to be very similar. It's just going to be this is going to be slightly different game, because you'll only be able to do clockwise turns if you just do this normal 6. And now we will make this out of paper. Alright, so here I have created the puzzle out of pen and paper. As you see, these are all the corners according to the SPEF's lettering scheme. These are all the edges according to the SPEF's lettering scheme. And then lastly, I have a piece of paper that wrote down all of the rules I described earlier for how these party guests at the dinner can move about. So now that I've done all this, I'm just going to perform a few moves to show proof of concept. So first I'm going to do a U move, which is going to be A corner, B corner, C corner, D corner cycles. So A goes to B, B goes to C, C goes to D, D goes back to A. And then that U move's also going to be F goes to R, goes to N, goes to J for the corners. F goes to R, goes to N, goes to J. And then we've got E goes to Q, goes to M, goes to I. E goes to Q, goes to M, goes to I, goes back to Q. And now we're on to edges for the U move. We got A goes to B, goes to C, goes to D. And then we've also got, let me read the paper. E goes to Q, goes to M, goes to I. So E goes to Q, goes to M, goes to I, goes back to Q. And now we have performed a U move. And you could do that again if you wanted to do a U2. So I could go on CS Timer right now and take a scramble and execute it on this piece of paper right now, and then I could solve it just like a normal cube. The only difference would be is that the presentation is not as compact, so it would be a little bit more time consuming to solve. But other than that, it's the exact same puzzle. And yeah, here I'll do one more move for you. So let's do a B move. So we got Q goes to R, goes to S, goes to T. For the Q, R. Alright, I've scrambled it. So yeah, right. Even though it's not Q goes to R, goes to S, it's the S position, so ideally there'd be labels at each of these spots. So like this would be labeled A, because this is where A belongs. This is where A was originally, so you kind of know where the seats need to be labeled, because they're not exactly here. But you can just go A, B, C, D, E, F, G, H, I, J, K, L to get the labels. It's just they're what I didn't label them. So what was it? B, so Q, R, S, T. And we got B, E, X, O. B, B goes to E, goes to X, goes to O, there we go. Lastly, we got A goes to H, goes to W, goes to N. A goes to H, goes to W, goes to N. Now we're on to the edges. we've got Q goes to R, goes to S, goes to T. Goes to R, goes to S, goes to... I messed that up. Q, this is the Q spot. Yep, it's just like that. And then we've lastly got A goes to H, goes to W, goes to N. A goes to H, goes to W, goes to N, goes back to... I might have messed that up. It's alright. So obviously that was a very difficult way to present the Rubik's Cube. It was just a proof of concept, but I did find a better way so that there are less physical mistakes possible. So what I did was I created a computer program that essentially simulates exactly what I just described. So these are all of these small numbers in the top left are all of the chairs, and then the big numbers are all of the party guests, and then these are all of the different ways these party guests can rearrange themselves. If I click execute, they do, and then it'll show up green if they are in the correct chair, and it'll show up red if they're not. And sorry, and scramble it, it'll do a bunch of party rearrangements, and then I can do my best to solve it. And yeah, so there is a much better way to actually do this, and I've got the actual cycles listed out here, and then a kind of visual framework for how to see what the rearrangements are on the left here. So in conclusion, you can make the Rubik's Cube out of paper. It's a very interesting and enlightening process that I partaked in. If you're not a coward, I encourage you to do so as well. And I just want to end off by saying that although I did this with the Rubik's Cube, I think you might be able to guess that you can do this with a large number of puzzles. And in fact, I believe that you can create any puzzle sold on thecubicle.com out of paper or simulated in my program. And if you don't believe me, please challenge me in the comments to do so with any one of your favorite puzzles from thecubicle.com, and I will do so. And I will see you soon. Amen.